Good afternoon, teacher. I'm Anastasia, and today I'm thrilled to introduce my final project for Advanced Interactive Programming Design. For this project, my topic is particles animation. So let's see. So before we will start, let's actually see what is particle system means. So it's actually a really powerful technique which is used in computer graphics to simulate physical phenomena such as fire, smoke, rain, and in our case, text animations. Each particle represents a small portion of the overall effect, and by controlling their behavior collectively, we can create stunning visual effects, as you can see in the poster reference. So they use a particle system to create all these design features. So there's actually 4 key points of this concept. So the first one is particles itself, so small individual elements that collectively form a complex visual effects, and each particle has properties such as position, velocity, acceleration, size, color, and lifespan. Then we also have emitters, so it's the source that generate particles, and emitters can have properties like emission, rate, direction, and initial velocity of particle. The next one is forces, so they affect on behavior of particles over time, and it usually includes gravity, wind, and friction. So basically it's our animation. And the last one is lifespan. So each particle has a finite lifespan after which it removed from the system, and it can be used to create fading effects or simulate particles dissipating over time. So here, as you can see, is a really basic example of particle system. So it creates a particle system and object parameterized to control the appearance and behavior of individual particle objects over time. So these particles have position and type and life for a set amount of time and then die. So as you can see, some of these properties are dynamic. So instead of using single color property scale, there is a star scale and end scale. So this allows you to specify the particle size transitions between the start and the end scale over the course of the particle's life. So start color and end color work similarly. Other ways of affecting the visual output include maximum and minimum attributes. So the actual value for that variable on the particle will be randomly assigned to be between the maximum and minimum input and stay statically at the value for the entire life of the particle. For example, use minimum speed and maximum speed as bounds for the randomly chosen speed of each particle. And at first, I'm gonna introduce my project. So there's actually 3 purposes. So the first one is enhance user engagement. So interactive elements like the text input bar encourage users to actively participate, increasing their engagement with the web page. Next one is modern web design. So incorporating cutting-edge animation techniques showcases the capability of modern web technologies and provides a contemporary feel to the website. And the last one is user experience improvement. So interactive and responsive design elements contribute to a better overall user experience by making the website more intuitive and enjoyable to use. So for this project, actually, I was thinking a lot of time what I actually can create after our midterm project and after our homeworks, and it was a bit tough. But at the end, I figured out that particle system actually looks pretty well, and you can actually make a lot of things for it. And I guess to make it interactive, I wanted to put a text so users can actually type their text, and it's gonna be generated by the particle system. And now let's dive to code explanation. So the first one is just a basic setup of Canva. So the following code setup and initialize HTML5 canvas and elements for rendering, graphics, and animation. The next step is particle system itself. So it's one of the most important. So each letter of the text is broken down into small particles, and we have constructors that initialize each particle with properties such as position, velocity, size, color, and force like friction and easy. Then we have draw method, so renders the particle as a small rectangle on the canvas. And we also have update methods, so updates the particle's position based on mouse interaction and applies force like friction and easing to move the particle smoothly. So the third one is effect class. So here we also have constructor, which is set up the canvas context, dimensions, text properties, and initialize an array for particles. It also set up mouse event listener and handles text input changes. The fourth one is text wrapping and particle conversion. So here we have wrap text method, which splits the input text into lines that fit within the canvas width and draws each line on the canvas. Then it calls convert to particles. And this method reads the pixel data of the rendered text from the canvas, and for each non-transparent pixel creates a new particle with the corresponding color and position. So here is the final step, so it's rendering and animation. So this process results in fluid and interactive visual effects where particles respond to user input and create dynamic animations on the canvas. So here we have a render method which updates and draws each particle, and we also have a resize method which adjusts the canvas dimensions and re-renders the text when the window is resized. So since a user needs to type their text, and each of the texts have different value, have different amount of words, so it will generate like the width will apply to the text itself. And the last one is animate function, so it clears the canvas and renders the particles, then requires the next animation frame. And also there's a CSS code, so basically here it's body, which prevents scrolling, then canvas, where we make a position and covers the entire window and applies a gradient background, and the last one is input, so it's a text box which assigns some of the design applies, like positioning and then color and fonts, and yeah. So what is my project reflection and challenges? So as I said before, the first one was choosing the animation system. So it was actually a critical decision because we already have tried similar designs, and so our choices was minimized. And since another challenge, it was time constraints, so I needed to make something in a short time, but it should look really visual appealing and have a good interaction. And I guess for this one, for all my requirements, particle system was one of the most convenient. Except these two things, I also have technical implementation. So implementing the project using vanilla JavaScript and Canvas required a solid understanding of JavaScript's objects-oriented programming principles. And actually, we have learned JavaScript for 1 semester, but since some of the things it's still quite challenging for me, so I have to make some researches and I have to watch a lot of tutorials video to create this code. And the next one is performance optimization. So since it's about particles and there's like 10,000 of particles which we're using in this system, so sometimes it was quite hard to make a smooth animation performance, and because it's include minimizing unnecessary computations, utilizing efficiency rendering methods, and handling canvas updates effectively. So I needed to deal with these issues as well. And also it's about learning and adaptation. So as I said before, JavaScript, it's still a pretty new environment for me, so I need to adapt for new techniques and technologies. And even if I know some basic knowledge about JavaScript, there are still a lot of things which I need to learn, and I need to find a way how to actually apply all of my knowledge into the coding system. So this is all for now for my final presentation.